Hello, welcome to our video on adding fractions with unlike denominators. Now, this may seem a little daunting for students because they want to just quickly add the numerators, add the denominators, and be done. But I always tell my students you can't add a dime and a nickel and say you have two quarters. Okay, we need to convert them to be the same thing before we can put them together. We can't add an orange and an apple and say we have two oranges. We need to convert them into fruit and then we can put them together and say we have two pieces of fruit. So if I have a pizza and I have a piece this large, and then I want to say, oh, I gave you two pieces, Michael. You got two pieces of pizza, but the other piece is split into many, many more pieces. I can't say that you got two pieces and have that be a fair or equal statement when I'm looking at these pictures. One of the pieces and slices is much, much smaller. And so I have to convert them into the same sizes mathematically. And once I am able to do that, then I can add my pieces together. And I know that picture is not the best, but it gives you a good kind of visual of what we're talking about with this. Okay, so I have explicit instructions on the left-hand side that we can follow whenever we're answering a problem like this. We can just look at these and follow these explicit instructions. And so when we are adding fractions with unlike denominators, we have to make sure to convert them to have the same denominator before we can operate. Multiplication and division is different. It's much simpler. You just make them proper and go across. But for adding fractions with unlike denominators, we have to make sure they have the same denomination and convert before we can put them together. So we need to work on equivalent fractions. The first step here, which is very important, is to put the problem in a vertical format. Meaning if I have a problem such as 2/5 plus 4/6, I used to have students work this way and then convert with equivalent fractions on either side, and they would get very, very confused. So we're going to start off by rewriting it vertically. 2/5 plus 4/6. And then we can work to make the equivalent fractions on the side. The second step is to circle the denominators. Numerator up top, denominator on the bottom. So N, D. So 5 is the denominator and 6 is the denominator. Now I'm finished with that step. Write out the multiples of the denominators until you have multiplied each denominator by the other, okay? This is an important step. So I'm going to write out the multiples of 5 until I get to 5 times 6. And I'm going to write up the multiples of 6 until I get to 6 times 5. In the beginning, there will be a time where you may not have to do that. But most likely, if you get there, if you do get there, you will find a common denominator and you have to find the lowest one. But you never have to go past the multiples of each other because 6 times 5 is going to be a common denominator. So I'm going to write down the multiples of 5 until I get to 6 5s. So 5, 10, 15, 20, 25, 30. There's 1, 2, 3, 4, 5, 6 5s. And then 6, 12, 18, 24, 30. Okay, 1, 2, 3, 4, 5, 6s. Then you want to scan and see, is there anything smaller than that 30 that they have in common? So I have 25, no. 20, no. 15, no. 10, no. 5, no. Okay, so that means that actually is our lowest common denominator. Sometimes there will be a smaller number that they have in common, and it'll be a little less work. Find the smallest number that is in common. We just did that. Next to the fraction with space in between, write the number in common as the new denominator. So I wrote 30 over here and 30 over here as the new denominator for both of these fractions. Fill in between an equation that makes the first denominator become the second denominator. In this case, we can use our multiples that we just wrote out. So how would we make 5 into 30? By multiplying or dividing. So 5, 1, 2, 3, 4, 5, 6 times. So I need to write in times 6 right here. And I'm going to get a different color because I think this is very important that students need to actually write in this part. So times 6. And that's true. 5 times 6 is 30. Now, whatever you do to the initial denominator, you need to multiply by the same form to make a new numerator. So if I times the bottom by 6, I times the top by 6. Because really, I'm cutting those 5 pieces into 6 sections to now make 30 sections. And so I need to do the same to the top to figure out how many sections 2/5 would be worth. And really, 6 over 6 is 1. So we're timesing by 1 here. This should be a giant 1. We're timesing by 1 to get the same number in a new form because any number times 1 is the same. So now we have 2 times 6, which is 12. So our new numerator is 12. 2/5 is the same as 12/30. And if you wanted to show with your class a picture representation, you can have your 2/5. And then each piece you're going to split into 6 pieces. You're going to get 6 pieces here and 6 pieces here. And then they'll see, oh, that's 12 pieces out of 6 times 5, which is 30. So we're splitting each one into 6 pieces. All right, then we go to our second fraction. Now, what can I fill into here? Same thing. Fill in between an equation that makes the first denominator become the second denominator. So how many 6's did it take to make 30? 1, 2, 3, 4, 5. So I need to multiply by 5. Whatever you do to the initial denominator, multiply by the same to form a new numerator. So I need to write in times 5. This is the important part, is this missing piece here, which equals 1. 5 over 5 is 1. So I'm going to get the same fraction in a different form. So 6 times 5 is 30. That's correct. 4 times 5 is 20. Okay. Now, finally, I can do my last step. Add your new numerators. Keep your denominator. 20 plus 12 is 32 over 30. Keep your denominator. Add your numerators. Keep your denominator because the piece sizes don't change. Now, if you wanted to make this into a mixed number, we would just say 32 divided by 30. Well, 30 over 30 is 1. 30 over 30 is 1. And we have 2/30. And then once you get to reductions, you would divide by 2 and end up getting with 1/15. But I think it's a good start just to get to here and then work on the conversion to improper at another time, or work on the conversion from improper to mixed at another time. All right, let's do another example. So this is an example where we want students to be able to see that maybe one of the denominators could just become the other denominator, and then we'd only have to convert one part of the fraction and not 2 parts. So for this problem, 1/2 plus 3/8, I'm going to put it in my vertical format first. Circle the denominators. Well, I have a 2 and an 8 here. And now my instructions tell me to go all the way until I've done 8 2's, which would get to 16, okay? And then do 8 until I also get to 16. But here, if I do my 2's, I'm going to see that 2 actually can go into 8. So instead of converting both into 16, I can just convert the 2 into an 8 because it goes in evenly. 8 is a multiple of 2. So I'm going to put equal, and then I'm going to put 8 next to the fraction with space in between. Write the number and comma as the new denominator. Okay. So now fill in the equation that makes the first denominator become the second one. So what do I do to 2 to make it become 8? I'm going to have to split it into more pieces. I'm going to have to split this half into more pieces for it to become eighths, okay? So to make the 2 an 8, I actually have to times it by 4, and that is true. So if I split each one of these sides into 4 pieces, now I have eighths, and I have 4 eighths, which 4 is half of 8. So if whatever I do to the bottom, whatever you do to the initial denominator, multiply to form a new numerator. So in order to times by 1, I need to times by 4 over 4. Whatever you do to the bottom, do to the top. Okay, so now I'm splitting the one piece into 4 sections. Here I split the whole thing into 4 sections, but I'm talking about one of the initial 2 pieces. Okay, I'm talking about one of those pieces, and I'm splitting it now into 4, or making it 4 times as many. It's like division and multiplication. They're both interacting here, right? We are dividing the one side into 4 pieces, but we're really making it 4 times as many pieces. So 1 times 4 is 4, and now I have the same denominator. So I have apples and apples, and now I can put them together, okay? So add my numerators, which is 4 and 3, and then keep my denominator. 4, 5, 6, 7, 7 eighths is what I would have here. Let's do one more. But if you follow these steps, you should be able to do any type of fraction. You can start to work on numbers that are mixed and add just the fractions and then add the whole numbers, or convert them to improper. There are a lot of different ways to tackle that type of problem, but with these instructions, you should be able to get a good grasp on it. I'll do another video on reduction tips to simplify fractions, and that will help get even further to a better concise answer. And so now I'm going to do 1/3 plus 4/5. So we ask ourselves, I put it in vertical format, do I have the same denominator here? Well, I have a 3 and a 5. Are those the same thing? No. If they were the same thing, then I would just add my numerators, keep my denominators. But they're not. So I'm going to write out the multiples of the denomination until I have multiplied by the other. Sometimes you'll find a factor sooner, but let's just write out 3 5 times and then 5 3 times. So 3, 6, 9, 12, 15. And then I'm going to write 5 3 times, 5, 10, 15, because I know that they both can go into 15 because they are both a part of the multiplication problem. Now, sometimes you'll scan and you'll see one sooner, but I don't see anything on both lists. 12 is not on both lists, 9 is not on both lists, 6 is not on both lists, 3. So I just see that 15. So we're going to be converting both into 15ths. So I'm going to convert this into 15ths and convert this into 15ths because they both need to be. So next to the fractions, I just wrote the number in common as a new denominator, okay? Now I need to fill in that equation. This is the part that a lot of kids might want to skip, or they'll figure out, oh, I times this by 3, and they'll put 3 as the new numerator. No, we need to fill in the equation, okay? So do not skip this step. Fill in between an equation that makes the first denominator become the second denominator. And whatever you do to the initial denominator, do the same to the numerator. Okay. So is 5 times 3 15? Yes. So that is the correct equation. So I times by 3 on top because 3 over 3 is 1. And really, I'm multiplying by 1 to get an equivalent fraction. 4 times 3 is 12. And then how would I make 3 15? And if I still had my numbers written out, I could see how many 3's it would be to become 15. And it is 5. So I need to multiply by 5 to equal 15. That's true. So whatever I do to the bottom, I need to do to the top because 5 over 5 is 1. Now I multiply across. 1 times 5 is 5. And now I have the same denominator, so I add my numerators and keep my denominator. 12 plus 5 is 17 over 15. You can leave it like this. Some teachers accept it like this. Or as we get into conversion, if you realize that 15 over 15 is 1,